Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is what is mathematical induction. Mathematical induction is a technique for proving results or establishing statements for natural numbers. This part illustrates the method through a variety of examples. Mathematical induction is a mathematical technique which is used to prove a statement, a formula, or a theorem is true for every natural number. This technique, mathematical induction, involves just two steps to prove a statement. Step 1 is base step. It proves that a statement is true for the initial value. We generally assume n is equal to 1 and prove that the statement is true. Second step is inductive step. It proves that if the statement is true for nth iteration or number n, then it is also true for n plus 1th iteration or number n plus 1. So this is the entire procedure. Let's see how to do it. We can start with regions of a circle. Consider a circle with n points on it. How many regions will the circle be divided into if each pair of points is connected with a chord? So let's see that. Please look at this circle. We have 2 points connected by a chord. So 2 regions. Am I right? So the regions can be written as 2 raised to 1. Same way, consider this circle. We have 3 points, so 3 chords. So the region we have 1, 2, 3, 4. This circle is divided into 4 regions. So this can be written as 2 raised to 2. Also consider these 2 circles. Here I have 4 points and we have 8 regions by connecting these 4 points. So this can be written as 2 raised to 3. Same way, for 5 points, we have 16 regions. This can be written as 2 raised to 4. At this point, probably everyone would be convinced that with 6 points, there would be 32 regions. Am I right? But it is not proved. It is just conjecture. The conjecture is that the number of regions when n points are connected is 2 raised to n minus 1. Hope you are clear with this point. Will finding the number of regions when there are 6 points on the circle prove the conjecture? No. If there are indeed 32 regions, all you have done is shown another example to support your conjecture. If there are not 32 regions, then you have proved the conjecture wrong. In fact, if you go ahead and try the circle with 6 points on it, you will find out that there are not 32 regions. You can never prove a conjecture is true by an example. But you can prove a conjecture is false by finding a counterexample. Hope you are clear with this point. So, to prove a conjecture is true, you need some more formal methods of proof. One of these methods is the principle of mathematical induction. Okay, let's see the principle of mathematical induction. Principle of mathematical induction is very simple. First, we have to show something works for the first time and assume that it works for this time, and then we will be showing it will work for the next time, and as a conclusion it works all the time. This is the principle of mathematical induction. Let's see how to describe this principle in mathematical version. First, you have to show the statement is true for n is equal to 1, and then you have to assume that statement will be true for n equal to k. And then you have to show that the statement is true for n is equal to k plus 1. And as a conclusion, you can say that statement is true for all n is greater than or equal to 1. The key word in this step 2 is assume. You are not trying to prove it is true for n equal to k. You are going to accept on faith that it is and show it is true for the next number k plus 1. If it later turns out that you get a contradiction, then assumption was wrong. That is the whole concept. Here is an example. Let us prove the statement is true by mathematical induction method. Okay. First step, we have to take n is equal to 1 and prove that the statement is true. So for n is equal to 1, it means 1 on the left side, and if you plug in 1 for this n, 1 square is equal to 1. Hence, step 1 is satisfied. Hope you're clear with this step. Okay, now let us move on to step 2. Let us assume that the statement is true for n equal to k. If it is true for k, just plug in k in this statement. So this statement is going to be true. It is just an assumption. We have to prove that the same statement holds true when n is equal to k plus 1. Let's prove this. So by distributing, we will get 1 plus 3 plus 5 to take 2k plus 2 minus 1. Now combining these two like terms, we will get 2k plus 1. So previous term would be, we know that this expression is equal to k square. Am I right? We are just going to substitute this in this place. 1 plus 3 plus 5 to 2k minus 1 is nothing but k square. So this entire expression till this term would be equal to k square. So let's substitute that. Now this looks like a quadratic expression, right? X square plus 2x plus 1. So similar to that, we have k square plus 2k plus 1, which is of the form a plus b the whole square format. So I'm going to rewrite this as k plus 1 the whole square. So 1 plus 3 plus 5 to 2k plus 1 minus 1, which is equal to k plus 1 the whole square is true. So this holds true, which satisfies the step 2. Hope you're clear so far. We started with n equal to 1 and we assumed that the statement is true for n equal to k. Using that concept, we proved that the statement is true when n is equal to k plus 1. So the statement would be true for all the n values. So the question is proved. This is how this technique mathematical induction works. Hope you're clear with this example. Let me give you one question very similar to this. You can try that problem in a similar way and check this technique works or not. You can let me know your feedback in the comment section. Here is your practice problem. You have to prove that 1 plus 4 plus 9 to n square is equal to n times n plus 1 times 2n plus 1 over 6 for all positive integers n. You have to proceed in the same way. You have to start with n is equal to 1. And then you have to assume the statement is true for n is equal to k. And then using the second step, you have to prove this statement is true for k plus 1. So from the mathematical induction, you can say that this statement is true for all n values. Hope you're clear with this concept. Know your answers in the feedback comment section. In all your mathematical induction problem, you have to give the conclusion. Conclusion is found by saying, therefore, by the principle of mathematical induction, we have proved whatever statement is given. So you have to restate the original claim. You should know also about the another form of mathematical induction. Strong induction is another form of mathematical induction. Through this induction technique, we can prove that a proportional function. This function is true for all positive integers n. Let me show you the steps to do this strong induction. Similar to mathematical induction, we have two important steps in strong induction. First one is the base step, second one is inductive step. Base step is nothing but it proves that the initial proportion p of 1 is true. And the inductive step is nothing but it proves that the conditional statement is true for all the positive integers k. The significance of mathematical induction cannot be understated. Nearly all areas of research in mathematics use induction. It is truly an indispensable tool for mathematicians. So using induction, we can conclude infinitely many statements are true just by checking two things. So this technique helps us to write a good proof for any kind of statement. So mathematical induction lets us use the property that if something is true for a smaller set, then it is also holds for a slightly larger set. If we use this property along with demonstrating that there exists a smallest set for which that particular thing is true, then it must be true for all the larger sets. Mathematical induction is nothing but method of proving, just like proof by contradiction. So in case if you get any query regarding this topic, kindly let me know. This method is very obvious. You can pick any statement from mathematics book and you can try the method. In case if you get any query regarding this topic, please let me know in the comment section. See you in the next video.